This video is going to cover our Open Roads Designer file management, how to organize your project and what goes with what. So the first part is the file naming convention for electronic plans. We have we're following the 237.13.2 electronic design data, and in here it calls out what the file naming convention should be. We have you can see the geometry files at the top. We have it'll be geometry underscore and then underscore job number, whatever that might be, .dgn. The microstation files, which contain the corridors and the graphic filters, super elevation, drainage, cross section, all that stuff, will name accordingly. So if you have corridors file, you would name it corridors underscore job number. If you have more than one corridor for the job, then you would call it out after the job number, give it whatever corridor it might be, Route 54, okay, or Ramp 4, or Ramp 2, or whatever you're going to do. You would call it corridors underscore job number underscore whatever corridor you want to call it, okay? So these are some standards that are out there for us so that it makes it easier for naming everything and we keep consistent with it. So that's the naming convention part. The work area that's created with them, with the files within ProjectWise, or is kind of like these are the files you get right out when you request a project to be created. You get the civil geometry, the corridors, drainage. You get all these files, and it'll have the job number behind it. So you'll get that. Now to talk about each file and what they do and what's good practice and not so good practice, we'll start off with the survey underscore job number.dgn. It is a 3D file. Anytime you're talking about a terrain file or a surface file, it's always going to be a 3D file. This 3D file is the original survey file to be used by survey only. Survey uses this file to create the two files for design, and that's the theory. That's the hope for most districts that we want to get to. But this file is their file. We don't want to use this in design. We want to use what they give us. So here, that's the survey file. The next one is the terrain existing underscore job number .dgn. It is also a 3D file. This 3D file is delivered from survey with existing terrain. The surface should have a surface feature definition applied to it, which will allow calculating earthwork among other processes. And I'm showing that off to the right. We have a feature definition of existing boundary there. I like to kind of do that in our main terrain existing file so that when you reference this file into another file, it shows up as a boundary and you don't have triangles everywhere and you have to go turn them off in that file. If you want to see your triangles, you can always go override the symbology and turn on that triangles. This file will not contain reference files. It'll be a standalone 3D file, and this file will be referenced by many files, mainly the civil geometry file, the corridors, cross sections. You can find a lot of information on the Road 1 manual. We have a video out there as well, Chapter 1. And in Road 2, we have in the Road 2 manual, Chapter 2, or a chapter in there called Advanced Terrain Modeling. It covers over a lot of stuff, especially when it comes to creating your surface for your electronic deliverables. So that's the terrain existing right here. Survey graphics is the other file that survey should be giving you. So you'll get a surface file that is your terrain, and then you'll get a surface file that has, it's a 3D file, and it will contain all the existing edge of pavement, shoulders, flow lines, any other data as simple elements. Now, in ORD, to use these elements for template points to target, an appropriate feature definition must be applied to them. And we've been kind of showing that as we've went around to the district showing Open Roads Designer that if you want to use the edge of pavement, you will have to give it a real edge of pavement that's in design and not use the survey stuff. They kind of broke that when we went to ORD. They took that away where we cannot now tag into a survey feature definition. So that's the only caveat. We talk about that in class a lot. So the next one is the civil geometry file underscore .dgn. It is a 2D file. The 2D file, it includes the horizontal and vertical, so you get your profiles, all the geometry such as your main alignments, ramps, side roads, anything that you want to consider an alignment, even like we do a bridge invent. It's considered an alignment in our class, so it gets put in this file here, the civil geometry file. This file will contain reference files of existing terrain. Mostly just that. You set it as active for profile creation and manipulation. You need it for that. Every now and then you'll see where you'll have to bring in your corridors. You want to tie your profile to an edge of pavement of something, so you'll bring it in. But it's good practice to bring it in, use it, create your profile, break the rules back to the corridor, and remove the corridor. Okay, so there's a lot to this one, but you don't want to leave other files referenced into this. It'll be referenced by your corridors, your cross section, super elevation, land boundary file, your plan profile, and this is we do a lot of going through the civil geometry in Road 1 manual, and we do have videos out there as well for chapters 2 and 3. Talks about how to create your horizontal alignments and how to create profiles, your vertical alignments. So that's a 2D file, and that 2D file. The civil geometry file is more like your backbone of your project, and that's why you don't want anything in there. You don't want anything to corrupt this file. You want this file to be alignments and profiles only, and it helps you along the way. Corridors is your meat and potatoes file. This is the one that contains everything. It is a 2D file. This file contains the corridor for the project. There may be more than one corridor per project, depending on the need, and you may have more than one corridors file. It depends on how large your corridors are. This file will contain reference files of existing terrain, and you want to set as active so the end conditions can solve. And then you have your civil geometry. You'll need that for your alignment, your profile access in order to create corridors. Without that, the corridor won't, without a profile, it won't be able to create it. And possibly other corridors might be referenced into this one. You might want them talking to each other and doing some clipping and target aliasing. So this file will be referenced by the cross-section file and possibly other corridor files. We do a lot of coverage on this in Road 1. We have in the manual, and we have videos on chapters 5 and 7. In Road 2, we do it with the ramp, intersection, and invent exercises. We cover a lot of information. This contains parametric constraints. It's got point controls. It's got in condition exceptions. It's loaded. This corridor has a lot of stuff. Okay, so and you don't want to run anything other than corridors in here, and you want to keep it a 2D file. If it's a 3D file, you're going to run into some major issues. So keep it a 2D file. Don't have anything in here. Name boundaries especially. Don't create name boundaries in here. Just use the corridors file for what it is. It's a corridors file that contains all the information for your project. And since it is such an important file, you really don't want anything else in there. In the drainage file, it's a 2D file as well. It contains all the drainage information for the project. Drainage should only be done in this file, and this file only. If you use it in another file, it's liable to have issues with the other tools. So that's why we kind of call that out with that. See drainage manual and videos for more information on this file and other files that go along with the drainage. The land boundary file, it is a 2D file. This 2D file contains property boundaries, property lines, section lines, right-of-way lines, and utility lines. Now, people are using them for utility lines to place them in there. To get your right-of-way or utility labels to show up in dynamic cross-section window and the cross-section models, the right-of-way element must have the correct feature definition as well as have an active profile. Okay, so there's a right-of-way line out there in this picture. If you had a utility, you could do the same thing. You just make sure that these things have the correct feature definition and they have an active profile. And what that's going to do for you, that's going to give you a label that goes to existing ground in your dynamic cross sections and in your cross sections. This file will contain reference files of existing terrain and some civil geometry. This file could be referenced by the corridors and the name boundary. And there's more information on this and what we do in Road 1 Manual Chapter 5. the plan underscore job number.dgn. That's a 2D file, and this 2D file contains any plan graphics such as proposed edge of pavement, edge of shoulder, that will be used for targeting purposes. Okay, and what we're saying here is that if you have an area where you want to transition, if you've got some pavement, you want it to transition from 12 foot out to 16 feet, or you're adding a lane in there, you go 12 foot to 24 foot, you could put a graphic out there and give it the proper feature definition. And in your template, you would seek that feature definition using the horizontal feature constraint. And when it sees that, as long as you make it a corridor reference, it'll draw out to that point. So you don't have to do multiple template drops to get that to work. You just do it by putting that element in this file. Okay, this file will contain reference files of existing terrain, civil geometry. This file could be referenced by the corridors. Mostly that's what it's used for, is by the corridors to seek any elements that you want to place into this file. And we cover that in Road 1 manual and videos of Chapter 5. Now we get into something a little different. It's the container file. I've been talking about it for a couple of years since we went into Open Roads Designer, but I go through it pretty good here. I want to make sure everybody understands it. Any name boundary file is considered a container file. And what they mean by container file is you just bring one file in and it contains everything for your job, your project. Okay, so, and that's where live nesting is used. Okay, and that's when the name boundary manager processes the drawing and sheet models, whether creating a new DGN file for plan sheets or cross-section models in the name boundary file itself. Live nesting can be used at a nested depth of 1 in a container file. Referencing the project corridor file with the nested depth of 1 will reference any and only the files it needed to create the corridor, which is really a cool thing. Using the hierarchy tool in the reference dialog will help manage the references from live nesting. And you can see I kind of got it hovered in this dialog. I got it outlined with these squares, the red squares. You open up that hierarchy tool. You might want to slide this open a little bit so you can see it. The first instance of it is the name of the file that we're in. And then the second one is the name boundary file. And then what you want to do is select the one that you referenced in, which would be that corridor Route 54, and you can see as I referenced it in this one, there's some grayed out ones. So the terrain was turned off and super elevation were turned off. Still brought them across, they're still there, they just haven't turned on the view. So what I would do is select this file, come over to the right side, and you're allowed to pick the super elevation or the terrain, and you'll see this icon right here will be unpressed. So you'll press it and boom, you'll get that to show up. So there's more stuff on this, and I'll talk about it in another video. But this is what a container file is. It's just bringing in one file. It's really simple to do. It's pretty quick and it's very handy. So container file. Now live nesting. Okay, we only use live nesting in container files, meaning name boundary files only. Okay, we don't want to use it in our corridors file. We don't want to use it in any other kind of file that we create. We want to just use it in a container file only, which is the name boundary stuff. And the way it works is you can see a nested depth of 1 down here. If I bring in the corridors file with a nested depth of 1, I'm going to get these files right here. Everything that created the corridors file. So I'll get my civil geometry, my plan, land boundary, super elevation, all this stuff will come along with it. Now, if you use a nested depth of 2, it's going to look at that civil geometry and say, hey, what's attached to it? Oh, the existing terrain. Well, let's bring it in. But I already have existing terrain. You're going to get 2 copies of it. Well, what about the survey graphics? Well, it's looking at existing terrain as well. So it's going to bring it in. What about the plan file? It's going to see civil geometry. It's going to bring it in. Well, we already have civil geometry. Same with nested depth 3. The more you keep bringing it, plan uses civil geometry using that existing terrain. It all comes in. You end up with 3-4 copies of each file. You don't want that. You don't want that at all. What will eventually happen is you'll have your corridors file referenced into your corridors file, the one you're in. That's a self-reference, which causes major issues. So if you use the nested depth of 1, you'll bring across just what you need for your corridor, no more. I hope that's clear. Now we'll go through the name boundaries, okay? So the name boundary for the plan, name boundary underscore plan, which is a 2D file. All these name boundary files are 2D. It contains, this file contains the geometry for cutting plan, and full plan sheets. That's what this one's for. This file will contain reference files. Now you can see it contains reference file by having yellow corridor. So if you use live nesting, you just bring in your corridor. You don't have to go select all the other files to bring across. Bring across corridor, live nesting of 1, boom, you're good to go. The reference file is referenced by all the created plan sheets in the DGN files that we create off of the plan. So see Road 1, the manual and videos for Chapter 9. We go through that. Name boundary profile is a 2D as well. Now this one's a little different when it comes to this. You won't be using live nesting on this one because what you're wanting to bring in, what it is it's a container file that contains the geometry for cutting profile, and full profile sheets. This file will contain the civil geometry file and existing terrain. You don't want anything else in there. You just want to do your civil geometry and your existing terrain. Okay, so that's how we build it, is with just using that, the profile. So this file is referenced by the created profile sheet DGN, and you can see more of that in Chapter 9 as well. Name boundary plan profile is also a 2D file, and this 2D container file contains the geometry for cutting plan and profile sheets. Again, here's where you can use live nesting again, okay? I got it in gold, you can start yellow, whatever color it is. But you can bring in the corridors file with that live nesting on, and you will get all the files that make up that corridor. And again, this is referenced by the created plan profile sheet drawings that we create, the DGN files. And more of this is in Chapter 9 of Road 1. Name boundary cross section. It is a 2D file as well. This 2D container file contains the geometry for cutting cross section drawing models and sheet models. Again, you can use the live nesting for this. It's a container file, so we can live nest our corridor in and get all the other information in there. Make sure you make your terrain active and go from there. Create on your cross sections, you have to have the 2D and the 3D models for it to work, then you're good. This file is referenced by the created plan profile. Nope, that is wrong. This is referenced by the models of each one, so that's all that is. That needs to be fixed. So see Road 1 manual and videos for Chapter 9. Super elevation is a 2D file as well. This 2D file contains the super elevation section, shapes for the alignment in which super elevation is being calculated. This file will only need the civil geometry file referenced into it to select the alignment to build from. This file will be referenced into the corridors file and used to apply the super elevation to the corridor. And there is a video out there in Road 1. We have it in the manual as well in Chapter 6 that covers in pretty good detail how super elevation works for one, and then how to apply it to your project. The graphic filter, this is a 3D file. I'm going to fix it right now. This is a 3D file. This 3D file is used for creating a 3D surface for the project for electronic deliverables. Okay, so this file will make use of a corridor referenced into this file to create a proposed surface. The file will contain the reference file corridor, mostly the corridor, and then after you create it, you pretty much detach it and use the surface as it is, and then you'll end up selecting that surface and then choosing an option to export to land XML, and that's how you'll get your electronic deliverables. You can see more of that in Road 2 manual. In the advanced terrain modeling, we cover 4 ways of doing it. Okay, now the way it works with all our files that we have out here, here's just kind of a graphic to cover it. We have our civil geometry file, existing terrain, our survey graphics, our plan, land boundaries, and super elevation. All this stuff is used to create the corridor. From the corridor, we can create name boundary cross-section models. Okay, that'll give us our drawing models and our sheet models. We can also create name boundary files. That gives us our plan sheets, our profile sheets, and our plan profile sheets. We can also use the corridor to create the graphical filter, which is your electronic deliverable surface. So that's basically how this all works together. Template point constraints, hierarchy of control. This is something that stumps a lot of people when they're working on their templates. So I wanted to throw this in the PowerPoint as well. The hierarchy of control, how this works. Well, a point control is used to modify the behavior of points in a template, and these controls take precedence over existing constraints on the point and are the highest form of constraint. So if you use a point control, it's going to override everything. Okay, so I'm going to start down at the bottom. Point constraints, number 4, the lowest form is a point constraint, and they're used to manage the behavior of points in a template. So if I look over on the right, this number 4, what I'm talking about, if I open a point property, I have a slope and I have a horizontal constraint. The slope says go minus 2%, the horizontal says 12 foot off. Okay, that's my lowest constraint. If later on I want to add a parametric constraint, which is a label that we create, we can create this label to say, hey, I want to change my asphalt width or my asphalt slope or whatever. I'd use that label, and you can see down here, number 3, if I use this label, I can override it 2% and make it whatever I want for the slope. If I use the width, I can say I don't want it at 12, I want it at 14 or whatever. You can override it using this label. That way you don't have to drop a new template. You just come out there, you use that parametric constraint label, and you can transition this as well. You can go from one station to another station, transitioning from 12 foot out to 16 foot out. Go down 16 foot for a while, and then come back for 16 foot back to 12. Whatever you want to do. But a parametric constraint will override these point constraints, which is really good. And then you have a horizontal feature constraint, which will override the horizontal constraint. So if you look at it down here, this is number 2, this is the second highest, it's a horizontal feature constraint. If that's toggled on and you're searching for this EOP new, and a lot of times that's what we want to do. We go out in that plan file, we draw an element out there, and we give it that feature definition of EOP new, and it matches what this template's looking for. It's going to go out from that point, and from this point, wherever it's at, it's going to look 50 feet, in this case, to the right because it's a positive. And if it finds that EOP new, it's going to draw to it, overriding what we do in the horizontal constraint and overriding if we had a parametric constraint. So this is one of the better ones. I like all of them, but these two are the best. Point control, it has a need and a use, but if you use it just for like horizontals, you're gonna find that it's gonna trip you up later because you're gonna want to use a point control to maybe tie to another existing edge of pavement or new edge of pavement that you're trying to tie to, and you've used that point control, and then you get to this part where there's a priority of 1 or 2 or whatever. One can solve and the other ones can't, so if it's a horizontal constraint, try to use either a parametric constraint or horizontal feature constraint to do a horizontal. If it has to do with horizontal and vertical, then I by all means use a point control. Okay, so that's the hierarchy. Let me go down and show how this works. So here's the point constraint here. You can see in the template properties, the point properties, we have a slope of 2% and a horizontal of 12%. So if I look over here, minus 2%. On that right side, and that's what I'm looking at, right, ASSERF TEOP, that'd be out here. It's going 12 foot over, minus 2%. Okay, so that's the way it's set. If I add a parametric constraint to it, and I say, hey, I want the parametric constraint to be this right pavement surface, whatever width, and then the right pavement surface asphalt slope, if I have those two parametric constraints created, and it says here that I want to do my width from out to 14 feet, and then my slope I want at 1.75. When I apply those parametric constraints, you can see in the dynamic cross sections what happens. So I go out, I go to my tool, I go to my hammer tool, and then go down to my parametric constraint tool, which is that large blue question mark. I fill these out how I want them, I apply them, and this is what it'll look like. It'll override what the point constraints are, the 12 and 20, the 12 and 2 that I have out there. Okay, so that's a parametric constraint. Again, here's a feature constraint. You can see that we have in the point properties box, we have our parametrics and we have these other point constraints, but we're adding a horizontal feature constraint. It's checked on and it's looking for EOP new. We have a line out here in our file and it says it's a 24-foot offset. So what's it doing? It's going out, it's finding 24 foot and using it. So that's how the horizontal, it only overrides the horizontal. That's what I'm showing in here is that it won't override your slopes. It just do your horizontal. And in the point control is the granddaddy of them all. It covers everything. And in this case here, it looks like we're using a vertical to actually control this ditch. So normally you'll probably use a both. You'll use the horizontal and vertical, but this is one way to say, hey, I want this point to go to this point, and that's it, and it will follow. Anything under that will do exactly what this says. And let me see, that pretty much is the end of the slideshow and the presentation. So I see that's it. That's all.